All right, and we are back tonight. First off, welcome back as we go through the home lab kind of migration process that we're doing. So far, we've kind of walked everybody through what the networks are supposed to look like on the first stream. Second stream, we talked about VLANs and migrating the VLANs across and how to set them all up. And then I also talked a little bit about the service catalog we did last night. I'm going to start with this just because it's a nice, pretty page. I've done some more just briefly today while I was doing some other stuff, getting the service catalog through Homar up and going. Some really cool things like some active integrations with Pi-hole, where it's actually showing data where I control the Pi-hole devices, showing temperature, all that stuff, just dashboard stuff. There's other cool things you could do, but I've also kind of split the core infrastructure components and some of the service stuff over here. But again, just a cool website to start with and go from there. Tonight, what we're going to do is we're going to start the actual migration. We've been kind of leading up to this. I've been talking about ProxMox. I've been showing the services. Matter of fact, I'll jump over into the ProxMox host here, or the cluster manager here. And all of these virtual machines down through here, whether they're on or off, are part of what I'm trying to convey to people, which is this isn't just like two or three things like a streaming server and a NAS. I'm trying to emulate what would actually be a small production network, or maybe even a small enterprise network, as far as what would be on it, whether it's observability tools, DNS, load balancers, Docker hosts. Eventually there's going to be Kubernetes clusters in here, Prometheus and Grafana, NetLab for network validation testing, a bunch of different stuff. Ansible hosts in here, so we can drive Ansible, and that host also does our Terraform. But anyways, the whole point about this is I'm trying to show that ProxMox and an environment like this can actually do a lot of really powerful things on not a ton of hardware if you're a small enough environment. Of course, the more you use it and the more people hit it, the more you need. So again, this is a home lab, but we're just going to go with that. So jumping from there, where we're at is last night we created VLAN 10 and 11. Not going to go back over all that, but what it means is that VLAN 10, our production, our future production network for all of our VMs that we're going to do, and I don't have the whole VLAN list up, but it's where all of our hosts are going to live eventually. And if we look at that, that's going to mean, so image master is going to be in VLAN 10. So it's going to have a 10.1.10.x address. And we're actually going to show a migration of image master specifically tonight. These two hosts that are right here, VLAN 10 test and image master, are going to be how we actually show what happens. So in order to show that things just work kind of from the jump, what we did today is we did a lot of prep, and that prep was to get PVE, or the first cluster host, fully up and doing VLANs. Because there's some interesting things, especially as you dig through the docs. And I found that, quite honestly, most of the doc stuff makes it way too complex. And there's a couple things that, I'll be honest, I don't fully understand about it yet. And I'm going to have to do some more research. But I wanted to go ahead and get this up and show you how it's working, because this is the bigger picture of what we're going to do. We're going to do a migration of all these hosts into these VLANs. We're going to continue doing our backups to our ProxMox backup server, which I'll show how we do all that process when we're done with the VLAN migrations. And then we're going to spin up the new ProxMox cluster manager. And at that point, what we're going to do is we're going to start migrating all of these over to that, and we're going to show that whole migration live of all of these services to show how fast it can be, to show what the pitfalls are and all of that. Because it's easy to say, oh, just migrate something, but there's a lot of planning to it. And, you know, even today, I've fallen through a couple holes in this process as I was prepping, and I've got notes all in front of me to remind me of those. And I'm kind of hoping I fall into a couple of those pitfalls again. If not, we'll fall into them in other places and we'll live troubleshoot them. But with that said, so if we go and we look at PVE1, we've got our primary public interface right now. there's a couple things we want to do with this. We want this interface from a management perspective to stay in the management network, which is VLAN 1 in this case, and is going to sit on the 192.168.1.x network. And that is exactly what we accomplished today. So not only were we able to keep this host in the management network as far as where its management interface was, we're able to now tag the individual VMs in the case of Image Master and VLAN 10 test to actually use VLAN 10 to communicate and to communicate on to other devices on the 10.1.10 network and outbound through routing. So just as a real high level, what we did is we made it VLAN aware. And this is the part where I'm not sure it's totally necessary. Originally, we made it VLAN aware, and we made VLAN 10. But in fooling around with it, I made the mistake and I made PVE VLAN or PVE2 VLAN aware, and I created a Linux VLAN for VLAN 10. But I actually created the hosts up in PVE1, and I didn't configure any of PVE1. Other than to go into my Cisco switch and set the port for .1Q trunking and with a native VLAN of 1, the management VLAN. So anything that's untagged would just communicate on VLAN 1, and anything that we tag will communicate on the VLAN that it's given. So I think there's some goofiness, but I think at the end of the day, ProxMox natively uses the interfaces on Linux, and maybe this is all Linux hosts, as kind of a trunk mode. And if you tag out of that, it will natively pass that trunking on. And if you're untagged, it'll natively just sit on VLAN 1 if the network is sitting in that configuration. So with that said, what I want to do is I want to show this stuff working. And we're going to go into here, and the very first thing we're going to do is we're going to go look at we're going to do the VLAN 10 test. Sorry, my bad. So the VLAN 10 test, if we go into this host, it's just a quick and dirty Ubuntu host that I spun up just for this point. I didn't want to move IP addresses. I didn't want to do anything. I just wanted to have a host on the VLAN 10 network that works. So if we go in here and we do an IPA, which we had already done, but you will look and you will see that this host is, if I can highlight it here, and I can't because I'm in this. But anyways, 10.1.10.25. That is what that host is. And it's up and working. I'm probably not going to need this a whole lot more, but this is what I want to show you. We're dealing with 10.1.10.25. So then I'm going to go down here to my PowerShell, and I'm going to ping 10.1.10.25, and I'm going to -t it. And it works. It's exactly as we would expect it to work. And the way we got that to work is not only did we set up the Cisco switch port interface to be a .1Q trunk going to the port that connects to PVE1, the cluster manager, for the production network. But we also made it, like I said, the untagged VLAN is VLAN 1. So all other VLANs are tagged, that one's untagged. And I can show you this a little bit here. We're going to bring this up. And as this is going on, you're going to see the ping continue. But I am going to go into the interface for the host. So this is the host VLAN 10 test. You can see it's on the bridged interface. That bridged interface is that one that I showed you earlier that we could make VLAN aware or not for our use case. And then I'm going to go to VLAN tag, and I'm just going to eliminate it. When you eliminate it, it says no VLAN, which means it's going to go untagged, which means it's natively going to communicate on VLAN 1 the way we're configured. You're not going to see any of that right now, but you will see it when we do the image master migration here in a little bit. So we're going to have that up, and I'm going to click OK. It's going to complete. And now because we've untagged it, it doesn't, my local host no longer knows how to, it doesn't have a path to it, a routing path, because that host is no longer talking on the VLAN that its gateway's on. It's just screaming into the standard LAN, and there's just no way to route to it. So if we go back into that, we're going to tag the host with VLAN 10 again. And it comes right back. So it's just a factor of tagging in this case. From there, what we're going to do is I'm going to leave this run, and we are now going to migrate this host, doing standard migration in ProxMox. I don't know if we've shown a migration live on screen, but I'll bring this up. But I'm going to right-click on the host that I want to migrate, and I want to migrate it. I only have one target node here. It's going to give me some warnings about it could take a long time. The good news is I have ZFS local-to-local replication going on. So even for really big volumes, it moves pretty quick. This 32 gig volume will go quick, and we'll actually show the full migration here. When we do this, you're going to see like a little paper airplane kind of icon pop up, and you're going to see a bunch of stuff happen. Then it's going to migrate down to PVE2. And honestly, my experience is we've only ever lost one ping on these. That said, we're going to lose a lot of pings here. I'm not going to follow the pings because that's not the purpose of this. Because we're migrating this to a host that is not set up for trunking. And then we're going to show it broken. Then I'm going to go through the process on the Cisco device to show you setting up the trunk port for this, showing you that PVE2's management interface still works. The host that we're moving here, so the VLAN 10 test still works, and then we'll be up and going. So then we'll have a VLAN capable cluster host. So here we go. We're going to hit migrate. It's going to run through all this. While it's doing this, I moved the stream to 1080p 60 in my recordings too. So I'm hoping you guys are getting a little bit better visuals on the stream and on the YouTube channel when we upload it later, and then when we hack this content up. But if you look, it's only moving 512 meg out of what was 32 gig because the rest is a sync. And if you look, we've got that little paper airplane. It's already gone. We're done. It's down here showing the little paper airplane. And this is just as it like completes the migration. It's done. So I don't even know. It says duration was 33 seconds. Don't know if that's dead accurate, but it was a really quick migration. All right, so we're going to kill the log file. We're going to go, and we're just going to go look at the ping right now because this is now dead. This goes right back to what I said. We are no longer able to hit 10.1.10.25 because the VLAN is not enabled on PVE2. So here's what we're going to do. Again, we're going to go look at our configs on PVE1. We made it VLAN aware. I'm telling you from testing, it made no difference. I think there's a whole different set of like sub-interface config type things that you do when you do that. But just by making the switch port a trunk, you seem to solve that problem or accomplish the goal. I'm going to do some more digging. We'll talk about it more later if I find there's a big difference. All right, so we go to PVE2. We're going to go to the Linux bridge. We're going to make it VLAN aware. At every stage of this, I am going to show you what we're doing as far as this. That still doesn't fix it. Now, the interesting thing is this. And you'll see this when we do the image master move. The image master move, we're actually going to have to tag and do some changes. We built VLAN 10 test, as a VLAN tagged VM from the get-go. So the tagging's already there. So once I do the port config changes, it's just going to come up. And we'll be able to see that without any other changes. So all I have to do at this point in time, other than make PVE VLAN aware, just to, if nothing else, to help my mind remember this is a VLAN tagged interface in the future. We are now going to go into MOBA Xterm. We are going to go to the 3560 Cisco switch for the shed. which is what that production interface is currently plugged into. Later, as we migrate the clusters, the production interfaces are all going to be on 10 gig, but for right now, they're on these 1 gig interfaces. So we're going to do show run just to show what we got. I can tell you that the interface that we're looking to change is gig 17. So if we come to right here, you can see I've already labeled it production PVE2. It's currently in mode access, which means, and it doesn't have a VLAN tag to it, which means it's in VLAN 1 as an access port. That's all there is to it. And right now, that host is on VLAN 1, the VLAN 1 IP address, and everything's working just how we would expect it. Other than the test VM that we moved that thinks that it's in VLAN, or that needs to be in VLAN 10 to communicate, and that's now what we're enabling. So here we go. We're going to go conf t. And if anybody wants to know, that stands for configure terminal. That's all it does, but it does shortcuts as well. And I'm used to the shortcuts. Haven't really brought that up yet. So we're going to do interface gigabit 0 / and we said it's 17. Like I said, I got notes all over in front of me. And then we're going to do show run int gig 0 / 17, just to again validate that's where I'm at. There's a lot going on. I've been doing a lot of prep for this video today. And then we're going to do switch port trunk encapsulation .1q. Then we're going to do switch port mode. Let's do this. Before we do that, let's go to this is the screen we're using to ping for this. Let's just prove it again, 10.1, 10.25. So we're going to ping for that. Let's also ping for 192.168.1.16, which is the IP address for the management interface for PVE2, the ProxMox cluster node. So here we go. We're pinging on it. I am going to, screen's going to get a little messy here. We're going to share these guys respectively side by side as we do this. What's going to happen here is I make this change, we are going to lose production access to PVE2. I want to point out one more thing here. If I was doing this in production, then the first thing I would have done, other than get the other host done, would have been a lot like what I did for PVE1. I got to find all this stuff. Sorry, I've got a bunch of other browsers back there. What I would have done is I would have migrated every single host to another member of the cluster before doing this. So migrate everything off one node, make the change, test it with a test VM, which is what we did with the test VLAN 10 VM. I would have then taken a non-critical host, in this case Image Master. It's a future service I'm building. It's not in use, but it's got to migrate. I would have made all the changes there, had all the learnings, screwed up with that stuff. We're not going to do that here because that's going to take a long time to migrate all this stuff. Even if everything's quick, it'll take too long to do right now. So we could get some bad things here. I could tell you for sure all of these are probably going to go red. PVE2 has been giving me some issues ever since I made the change, so I think there's some cluster things going on since I made the change, but we'll ignore that for now. We can still access it, do all the work we need to do. And then, but again, all these services that are currently existing on PVE2, I expect them to all go red. And we can show that because this just shows, uptime and all that good stuff. And you can see them kind of all go red and green and all that. So here we go. We are going to go down here, back to the switch. We're going to pull up our pings again. We're going to leave the ping up for PVE2 so we can watch it go down. So we're going to do switch port mode trunk. And the other thing is it might not go down because I have not defined a default VLAN, so an untagged VLAN. I'm going to. But it might natively just say, oh, we haven't defined it, it's still 1. That's the problem with using VLAN 1, is a lot of things just by default say VLAN 1. That's why a lot of people don't like using VLAN 1 for like management and stuff, among other reasons. Switch port mode trunk, and here we go. Nope, it definitely killed it. And we're going to watch this timeout here. There goes the timeout. And then we're going to go back into this. We're going to do switch port trunk native VLAN is going to be 1. This should resolve the issue with PVE2. And I say should because it doesn't appear that it is. There we go. Resolved it. And at the same time, so it was probably just spanning tree coming up, 10.1.10.25 is now talking on the same interface as the management interface, but they're talking on 2 VLANs. Single interface, 2 VLANs. VLAN 1 for the 192.168.16 and VLAN 10 for the 10.1.10.25 address. And we're live. It's that simple. We're going to keep that up, and I'm going to show you a little bit about what I meant. We didn't even jump back to here. These probably all kind of flaked, did their thing, came back, whatever. Not a big deal. Not going to worry about it. We go into the cluster. The cluster's happy. The cluster's not throwing any issues. If we go over here and actually look at the summary, cluster status is up. The quorum is good. 2 nodes online. Everything's good. Like, it was that simple, but it took a lot of planning to kind of get there and understand what we were doing today. So I am going to show you a couple other things real quick since we're in here. I am going to make that the primary window. I'm going to go back to our pings because what I want to show you is if we go into PVE2 now, we know based on everything that we just did that 10.1.10.25 is being tagged. I showed you disabling the tagging, it breaks, all that. Tagging's working. That's awesome. VLANs are working. This is where my confusion comes in a little bit, and that is that if you tell this interface to not be VLAN aware, if you tell the interface that this is currently talking out to no longer be VLAN aware, we make the change. It's implemented on the back end in the Linux config. You can see the changes that are made right here. Nothing breaks. It's fine. So I think I think by its native usage, what Linux is doing, or at least the way ProxMox has it configured, is by default, the ports are already kind of in a trunk type mode to the OS. I've got to do some more digging on that. But again, I'm going to go back into the bridge. I'm going to tell it I want it to be VLAN aware. I'm going to click OK. And then you're going to see bridge port, spanning tree off, VLAN aware, yes. Bridge IDs 2 through 4094, which we talked about the other day, which is pretty much the whole VLAN stack. We're not bridging 1 because 1's untagged. So that's it. It works. That's really cool, and that's what we expected. Here's the other cool thing. Now that we have got all this set up, I am going to kill the ping to 192.168.116. We don't need it anymore. But I am going to show you what happens if we go back to VLAN 10 test now and we migrate it. And I'll just let the pings run. And I will show you, because of the storage synchronization that we have going every 15 minutes, how quick it will migrate effectively a 32 gig volume in full OS and how many pings you'll lose. Now, different applications will be less resilient to this type of move and stuff like that, and the latency. Not worried about that. I'm just showing CoreOS, what the migration looks like and what you do. So here we go. We're going to send it to PVE1. We're going to migrate. We'll leave the log up so you guys can see exactly what's happening. Keep in mind the migrations and the replication are all happening on the 10 gig switch, not on the 1 gig switch. That's all a different part of the setup. And you look, it's going to say it's going to migrate, or it's going to synchronize 4 gigs and actively transfer. It's done. That quick, done. And now it's going to move it. There's your 1 ping lost, and now we're live. So we lost 1 ping between all of that. We wouldn't have even have lost an SSH session during that. And if we look, I think this is complete, done. Yeah, task okay. So we're done. So that's that. The next thing we need to do is we actually need to migrate a host. So we're going to go ahead and kill the ping to 10.1.10.25. And we're going to close this, because the next one we're going to do is we're going to show how this works with actually migrating a host. So if we go into Image Master right now, Image Master right now has an IP address of 192.168.1.220. So if I go in here and I ping 192.168.1.220 -t, we get the host. What we're going to do is we're going to make this host, or we're going to make the host's IP 20, actually. So right now, if we're pinging 20, there's nothing there. No host sits in VLAN 10 at 10.1.10.20. Just doesn't exist. But a host does sit in VLAN 1 as 192.168.1.220. Again, I'm going to throw some caveats out here that as we go through this, applications will have to be changed. Not every application just pulls all of its stuff. It goes, oh, the IP of this, there's hard-coded things in apps. We will break things as we move through this, and I'm going to figure those out, and we'll figure them out together. But the more complex the application, the more likely that you're going to break things. Like I'm not interested in really taking a functioning Kubernetes cluster and migrating it to another VLAN. When I stand up the Kubernetes cluster, I'm going to stand it up in the VLAN it lives in because there are a lot of moving parts there. So that just is what it is. But keep in mind, this is raw OS. This is just us showing the base process. So the very first thing we're going to do is I am going to go into the host. And I am consoled in here. This is one of the cool things that when you're in ProxMox and you have admin access to it, when you double click on a host, you're actually getting a VNC terminal to it, just like you had a monitor. I can't copy and paste to it, which is annoying, but it doesn't matter whether it loses the IP. As long as I have management access to ProxMox, I have access to all my VMs. So if I go in here, and I've done this a couple times today, we are going to go into the NetPlan YAML file, which is how you define the IP address and such of these Unix boxes or these Linux boxes. And right here you'll see it is 192.168.1.220. I am going to pre-prep changing that. So what I'm going to do is I'm going to take this to 10. And I got to be careful with that. Because you're in this console type mode, it doesn't like it when numlock's on. So 10.1.10.20. And again, something it didn't like. All right, and then we got to go change the default gateway. So 10.1.10.1, and we're done. Like I've gone through this. I made sure that my YAML file was architected right and everything earlier because I had a couple goofy issues with it. And anybody who knows NetPlan and the YAML file, it kind of changes and things get pulled and pushed. All this should work just seamlessly at this point. Our DNS addressing stays the same. So it's still using 192.168.1.2, which goes to the Kemp, gets the load balance between the two pie holes, and then the backup to go to public is 1.1.1.1, which is Cloudflare. So all that's the same. We're going to go ahead and save this file, and then we're going to queue up sudo netplan apply. I am not going to do it yet. We want this to be as quick and seamless as possible. Like you can see, even though I made the change to the file, we haven't applied it. This device hasn't gone ahead and made the changes, but they're queued up, ready to go. So now what we're going to do is we're going to go ahead and tag the VLAN on this host in its hardware. So we're going to go to the hardware config in ProxMox. We're going to go to the network device. I also think there might be some ways to add another network device to this and make it happen cleaner. But again, things for a different day. This is just a hard cutover. So we're going to tag to 10. That's all we're going to do. We're going to change nothing else. We're still on that same VM bridge 0 that we just made the config change for. That's technically the single gig interface that's hooked to it. It's not technically, it is. And then we're going to hit OK. Oh, sorry. I said we were going to, no, we're going to make it 10. And I've got to reset my numlock again. So we're going to make it 10. It was untagged, so on VLAN 1. It's now tagged to VLAN 10. And if we look at this, 10.1.10.20 is not talking. 192.168.1.220 is, and I'm going to hit apply or OK. We've now tagged that VM and it's dying. And if everything works right, if I did everything right, oh, I didn't do everything right because I said we're going to have it prepped and we're going to do net plan apply. We do net plan apply and you see almost instantly 10.1.10.20 is now talking. So now the tagged host is working. We apply the new config. We do IP. Let's do this again. We do IPA. And that shows us we are 10.1, 10.20. We're getting full responses. And we migrated that host. Here's the other cool thing about this, just like we did with the other one. Now that both of the cluster members are configured for all this, we can migrate this host to the other cluster. So we're going to do a migration. And again, it's got the same synchronization and everything as the other one. And it's a much bigger volume. I want to say it's 200 or 500 gig. And it is not going to take that long. We'll see it happen here as it does the replication and the snapshots and everything. But even though it's a much bigger disk that it's migrating, it's only migrating effectively the differences between the synchronization. And again, it needed about 4 gig. Not a lot of change going on these things. It's already been storage migrated to the other host, and it's already coming up on the other host. It's live. We lost 1 packet. It's done. That's it. That is the core of what I wanted to show everybody tonight. We are, 32 minutes in. I didn't expect this to be a long stream. I am going to do some documentation on this and make that available on StaticNet. That stuff's all coming later. But this is what we're doing. This is what we've been setting up for. We've been setting up so we can actually start doing the VLAN tagging. So we can start having segmentation between management and host. The other thing is we could have segmentation between types of servers. We could have more secure zones, less secure zones. That's all to come. But that's it. This was not super hard. Spent a lot of time today kind of beating my head on it, so you guys didn't have to. But this is, in my mind, the first stage of our actual cutover and the migration that we've kind of been talking about throughout the lab stuff. Beyond that, I wanted to bring up a couple of just real basic things. So if we go back to the host and we look at the networks, so I had talked about this a little bit and said that right now we have the existing ones. So we have the cluster interface, which is the 25 gig, and there I'll show how to configure all that when we rebuild the cluster. But that is what migration happens on. That's what storage replication happens on, all that good stuff. Down here we have the cluster CoreOSync interface. We've talked about CoreOSync before. But what's interesting about all of these right now, up until I made the change to VLAN 10 today, none of these interfaces live in a different VLAN other than one. So you're like, hold on, I thought 192.168.1 lived in VLAN 1. It is. It's the routed VLAN on it. But just like a switch, if all the ports are talking on the same switch and people are just screaming, with ARP requests and stuff like that, and they're on the same wire, they're going to hear each other and talk to each other. So we haven't migrated the interfaces for things like CoreOSync yet. I will probably do a quick video on that later or part of another discussion because I want to have all this stuff migrated and done and right before we do the big migration. But the reality is it's working just fine. And I can even show you. So the interface for CoreOSync on the switch, let's go back to the switch. And I don't think I have it labeled, but I do have a note here that tells me what it is. So if we go to the shed switch again, it should be port 18 and port 20. So if we do show run. And we get down into our ports, and you look at port 18, and so there's 18, and it's screwy because we had done trunking stuff and it didn't get pulled, but it's in access mode. And it's in access mode without a defined VLAN, so there's no switch port mode access, which means it's in VLAN 1 by default. And then you go down to 20, and it's doing the exact same thing. So they're sitting in VLAN 1. Screw it. We already have defined VLAN 11. VLAN 11 is on here. Let's just do it tonight and let's see what we break. Why not? It's the whole point of the lab, and we're under an hour, and we'll stay under an hour tonight. So if we do show VLAN, we're just going to check ourselves here. VLAN 11 is there. We're going to then go into show run again. I want to clean up that one config tidbit on 18 before we do it. I'm going to make a note that we're dealing with 18 and 20 here. So 18 and 20, we're moving them to VLAN 11. And we're going to do the thing that I've said before. We're going to show it break. I'll go to the cluster management, and I will, after I make the change, I'll show that one cluster node's down, and we'll see what that does. And hopefully it doesn't frag the whole thing. If it does, then it's going to be a fun night to get back to this point. So from there, we're going to go into conft. I am going to go up, and I am going to grab switch port trunk allowed, copy it. I'm going to go to int gigabit 0/18, do no. We're going to paste, no, not copy. I just messed all that up. Let's go back up here to 18, switch port. We're going to grab that. We're going to copy it. We're going to do no. We're going to paste. We're going to get rid of the extra space. Then we're going to do show run int gig 0/18. And there it is, switch port mode access. That's all it is. So we're going to do that. And then we're going to do show run int gigabit 0/20. Switch port mode access. We're now going to do switch port. Remember, right now we are in port 18 still. Port 18 should be the interface for PVE2. We'll know in a minute. So we're going to do switch port mode, or switch port access VLAN 11. Boom. All right. So then I'm going to go back to my config here, and we're going to go to the cluster management, and already PVE2 dropped. You see it gone. It's up. Its hosts are still talking. Matter of fact, I'm betting all of these things are still accessible. The Kemp's on it. I can click the Kemp. Kemp comes right up. So all its hosts are accessible. As far as ProxMox and the cluster is concerned, though, it is gone because we nuked its communication. We split the communication between VLAN 11 and VLAN 1. We're going to fix that. We don't have to change IPs here. We're not looking to change IPs. We're just moving the interfaces to different VLANs. So we're then going to go back into the config. We're going to exit this. We are then going to do, you know what? We're going to go back to that one more time. And we're going to do description, and we're going to do PVE to CoreOSync. We're going to exit that. We're going to do int gigabit 0/20 because that's our next interface. We're going to do description PVE1 CoreOSync. That, and we're going to do switch port access VLAN 11. If I can type, then we are going to go back to here. They're still showing segmented. And there they go. Came back online. Took a probably 15-20 seconds for CoreOSync to figure its whole thing out. But now we have the CoreOSync network in its own private VLAN, communicating only between two switch ports. And here's the other thing: we know. We don't know. We can't show the whole routing thing because right now, if you go look, the interfaces. This goes back to the whole thing that VLANs and IPs are separate. It's L2 and L3. They're in the same VLAN so they can talk. That's all that matters as far as the communication goes. But if you look at this, got to find it again. So we got to go to PV1, and then we'll go to network, and then we go to the cluster CoreOSyncs. Right now, this VLAN is set up for 10.1.2.10. In reality, the VLAN gateway is 10.1.11.1. So it's the 11 VLAN. And this is just because these used to just be wired server to server with just a cable connecting them. And now they're in there. And when I first did this, I hadn't had all the IP planned for the big network and lab change setup, which is kind of better. It's how life works. It's how production works. You do something, and then 4 years later, you got to do something. You're like, crap, we didn't plan for that. That's kind of where we are. So as we bring up the new clusters, and I can even re-IP the cluster interfaces, but I don't want to cause that hassle. But as we bring up the new cluster, it will be in 10.1.11. And that cluster will be separate from this, but we're just going to reutilize VLAN 11 instead of building a bunch of like transitionary networks because there's no reason to. So with that, we have done a couple different things. We've transitioned CoreOSync into its correct VLAN tonight, and we have also enabled VLANs, VLAN 10 across the production interfaces for both PVE1 and PVE2. And we've already done a test with a VM that shows that works, and it can migrate without losing more than one packet. And then we have also done a transition of a host from untagged on VLAN 1 to tagged on VLAN 10 on those interfaces, and changed the IP address in the netplan config and brought it up, and it works. And I guess the final thing, just to kind of show everybody if there's interest, because right now in the current configuration, everything can handle it. So I said what I would do is if we were doing this in production, I would have got everything up PVE2 other than the test VM to try this. So here we go. I'm going to do a bulk migrate. You can go in and you can choose individuals if you're just trying to take load off a box or move certain services off to test things. In this case, I want to clear the host. This is abandoned ship. All of these should be synced, but I am going to go ahead and just hit migrate now. And I have no idea how long it's going to take, but I am just going to let that ride. And what it does, it individually does it. You can kind of see down here, I did the bulk migrate. And then what it does is it starts the migration for individual hosts. And if you look at this, each one of them is probably going to move about 4 gig. And on that note, I don't really have a whole lot more to say to everybody. I'm just going to let this complete, and I will go with that. And when the migration's done, I will go ahead and close the stream. I hope you've enjoyed it. I hope it's been helpful for you. And, you know, this is exciting for me. There's a lot more cool stuff to come. So I'm going to mute out, and I will talk to you soon. All right, and that's it. If you guys have never seen a full migration on a ProxMox host before or a cluster before, that's what it does. That's the cool thing about having the cluster. For those of you who are looking at this from a home lab perspective, I've seen a bunch of questions in the forums that have been like, why would you do a cluster? Well, this is one of the reasons. You can do service on your host. You can have one fail in HA mode, which we're going to do more on later. If a host fails, the others will reinstantiate themselves automatically if it's in an HA mode. That is pretty impressive in my mind. Now, a lot of these aren't active, and the ones that aren't active go quicker because there's not the memory dump and everything that goes with it. But at the same time, for free on a bunch of old hardware, that's not a bad gig. And you did see that the memory jumped up, CPU jumped up, and we became a lot more constrained. And then I/O delay is a lot heavier when you're on a single host, especially a ZFS, and there's a lot of disk calls. But yeah, that's it. It's done, and everything is over on PVE1 now. I am gonna reset a bunch of this offline so you don't have to watch it again. But I at least wanted everybody to kind of see what it would look like if you were going to do a migration. We'll do this again, but I probably won't ever make you guys sit through that again. But anyways, again, thanks for coming. It's been great. I hope it's been educational for you all, and this will be posted later on YouTube as well. Have a great night, everybody.